Hi students, we are in the process of studying complement arithmetic. We are going to look at complement arithmetic in the octal number system. The radix complement for the octal number system is the 8's complement. All of you by now know that in order to find the 8's complement of an octal number, you have to add 1 to the LSD of the 7's complement of that number. Obviously, there is a method to do 8's complement arithmetic and it looks like this. You will understand each of these steps with the working of an example. There is a subtle difference between 7's complement and 8's complement. I will give you a minute to notice the difference. Well, the difference is right here. In the 8's complement arithmetic, you ignore the carry. Also, this method is very similar to the 10's complement arithmetic that we have learnt in a previous video. Let's take an example. 462 minus 175. Note that both these numbers are in octal. In subtraction, the first number is called as the minuend and the second number is the subtrahend. Let us also bring up the algorithm that we saw in the previous step. The first step tells us to add the 8's complement of the subtrahend to the minuend. The subtrahend in this case is 175. Find its 7's complement by subtracting each digit from 7. We get 602. Now simply add 1 to the LSD to get the 8's complement as 603. The algorithm also tells us to add this to the minuend, which is 462. So adding this up, we will get an answer. Now remember that this addition is an octal. So 3 plus 2 is equal to 5 in decimal, which is valid in octal also. We get the sum in the first column as 5. In the next column we have 0 plus 6 is equal to 6. Which is also valid in octal. So 6 comes as the sum in the second column. In the last column we have 6 plus 4 is equal to 10, which is in decimal. Converting this to octal gives you 12, that is 2 with a carry of 1. So we get the sum as 1264, where the MSD 1 is the carry out from addition. I have highlighted this in grey. Now this carry you have to ignore. The algorithm also tells us that if there is a carry, then the answer is positive, which is pretty obvious since the first number is bigger than the second number. So by ignoring the carry, we get the answer 265, which is the answer that we are looking for. There is another step in the algorithm, but we will tackle that in the next example. Let's rearrange those numbers and write it as 175 minus 462. Let us also bring up the algorithm that we saw in the previous slide. The first step tells us to add the 8's complement of the subtrahend to the minuend. The subtrahend in this case is 462. Find its 7's complement by subtracting each digit from 7. We get 315. Now add 1 to the LSD to get its 8's complement as 316. The first step also tells us to add this value to the minuend, which is 175. Now remember that this addition is an octal. So 5 plus 6 is equal to 11 in decimal, which when you convert to octal gives you 13. So the result of the first column's addition will be 3 with a carry of 1. In the second column we have 1 plus 1 plus 7, which is equal to 9 in decimal, which translates to 11 in octal. So we have the sum of 1 and there will be a carry of 1. In the last column we will have 1 plus 3 plus 1, which is equal to 5 in decimal, which in octal is 5 as well. So you get the sum in the third column as 5. The final sum is 513. Notice that we have no carry. The algorithm tells us if that there is no carry, then the answer is negative and it is in 8's complement form. We need to find the 8's complement of the result to get the final answer. So finding the 8's complement of 513, we begin by first finding its 7th complement. We get the answer as 264. Now add 1 to the LSD to get 265, which is the answer that we are looking for. Since the result of subtraction is negative, don't forget to put the minus sign. That's all for now. So if you may have noticed that there is a lot of similarity in these algorithms. So I am going to exploit this and leave hexadecimal complement arithmetic for you to explore by yourself. I will give you a few hints though. In the hexadecimal complement arithmetic system, the 15th complement is very much similar to the 7th complement method, which is also similar to the 9th complement arithmetic method. In the same way, 16th complement is similar to 8th complement is similar to 10th complement. In fact, the difference is only in how they handle the carry. Stay connected to the classroom for more videos and learning material. Thank you.